Hi everyone, welcome to my channel. Aditya here. Today we are going to continue our coding problems and I'm going to discuss today about reversing a linked list. So reversing a linked list is a very famous problem. Usually most of the interviewers ask this kind of questions because this is a little bit tricky and this comes under linked list section, right? So how to reverse a linked list? So the question, we will go through the question first. So implement a method called reverse that reverses the order of the nodes in the linked list. So we are clear, right? They have given a linked list, we have to reverse the linked list. But we have a constraint here. What was that? When solving, we are not allowed to create a new list. That means no new lists are allowed. So you have to work on the same linked list. And another constraint is use on any additional data structures besides the linked list itself. That means you are not supposed to use any other data structure, right? We know the stack data structure. We can add one by one nodes to the stack, and if we pop them, we will get a reverse of linked list. But that is not the way you have to do, because you have to follow this constraint where you are not supposed to create any additional data structures. So you have to work on the same linked list itself that is in place, right? You are doing an in place algorithm now, and you are not going to create any additional data structure. In fact, any other linked list also. So you have to work on the same linked list. So the other point they have given is they must reverse the nodes in the existing linked list by manipulating the pointers between them. You have to manipulate the pointers between them, but not to create any additional data structure. I think we are clear here. So we have to reverse the linked list without using any additional data structures. Fine. So we'll see the examples now. So if you see the first example, they have provided the input as head points to 1 and tail points to 5, right? Since tail points to 5, the next pointer of the tail is null. So they have given head and tail and also the linked list like this. So 1, 2, 3, 4, 5. So we have this 5 nodes. Now you have to reverse this linked list like this. So this is the output. Now the header is pointing to 5, which came front now, and tail is pointing to 1, which went to end. And the pointers between the linked list has been reversed like this. So 5 is pointing to 4, 4 is pointing to 3, 3 is pointing to 2, and 2 is pointing to 1 like this. 5, 4, 3, 2, 1. So we have to achieve this. Okay, before going into writing code, right, we'll have a look how can we achieve this. Yeah, so this is the linked list representation. Now we'll see how can we reverse it. So I am just placing this a little bit above. Okay, now we'll try to reverse it. So before reversing it, we will create few more pointers. The first pointer is that points to the current node. Okay, I'm giving some other color. This points to current node. So initially this points to head itself. Okay, and here the head is represented by green color, and we'll change the tail to some other color. So this is tail now, and this pointer is represents current, and we have to take two more pointers points to the previous. So in starting at start, the previous pointer will point to a null. So there is no node here, it points to a null. Now the previous pointer will points to the node which is not there. As of now, this node is not there here because one is head and this could be the some null node. So I name it as null. This is null node and previous is pointing to null node. So I am representing previous value with some other colors. So I will use some purple. So purple represents the previous node, pink represents the current node, and we need a reference for the next node. Here I'm going to point to the next node like this. So we will give some other color to color to this node. Yeah, we'll give some this dark color. Okay. So this purple color represents the previous node. This pink represents the current node and dark color represents this dark green color represents the next node. Okay, previous, current, next. Now we'll try to implement our logic. Okay, here this arrow is representing in the wrong direction. First, I'm going to delete that. Is this okay? Okay, fine, right? A previous pointer which is purple, which is pointing to a null node, which is not there, but we are just imagining. And we have our head which is pointing to this green pointer, and also the pink, which is the current node. So initially we start with the head pointer, and we have the next element. We are pointing the next element with this dark green, and we can say the current dot next is the next element. And we have our chain, right? We have our chain, and at the end we have the tail point. Now we'll try to apply the logic. So initially what we are going to do is we are going to loop through this linked list like this. So we'll start from head, we'll go through like this. And before that, we are going to do is we are going to change the head and tail pointers. So initially we will point head to tail, and the current head to tail, and tail is our, so the head, now we have reversed head and tail. So the head and tail has been reversed. Now we'll try to loop through from this linked list. So initially we stored the head pointer here in this current element. So even though we move the head to end, no issue because we have kept that pointer in this, kept that reference in this pointer. Now we'll try to go through this and apply the logic. Okay. The first thing we will do is we will always put this after pointer to keep our, after our next pointer, to keep the chain alive. After, okay, after equal to current dot next. Okay, that is now pointing to 2, and current is now here, right, in the first node. Now we are going to, what we are going to do is we are going to break chain between 1 and 2. That means current and after nodes. Like, since 1 dot next is pointing to 2, we are going to remove that. Instead of removing, after removing, we are going to point like this. So we are going to point to null. Okay, it's pointed to the previous one. Now we are moving previous to the current value. For simplicity's sake, I am moving these 2 pointers above like this. Okay, so now we will move the previous equal to current. Okay, and current equal to after like this. Now pointer has been moved. The next step what we will do is, so one iteration completed. So we have break the chain between these two, but we have after to keep the reference, right? And now we have current move to 2 and previous move to 1 step forward, and current also move to 1 step forward, and after is there in its place only. The next iteration again we will do the same thing. So the after is nothing but current dot next, that is 3. Now after is kept here to keep the reference of the chain, and 2 is the current node which is pointing to the current node. Now we are going to break this chain, like deleting this chain, and we'll point these two. So that means current dot next equal to previous. So the chain is break, but no worries because we have after pointer which keep the chain alive for us. Now we will do is we will move previous to the current pointer and current to after. Okay, like this. Again in the next iteration, we move our after pointer to current dot next. So since current pointing to 3, we will go to the current dot next. Now we have to break this chain. So how can we break this chain? Simply pointing this dot next to its previous value. So we have to delete this and point to this. Okay. So current dot next equal to previous. Now previous has to be changed like this. So previous pointer is previous equal to current, and now current equal to after, right? And the loop completes. So in the next iteration, we are going to change the after to current dot next, that is 5. And now we are going to break this chain. So how can we break this chain? Current dot next equal to previous value, right? So if we do that, this chain will be, this link will be broken, and we are going to add a link to previous element. Now previous will move to the current. Okay, and current will move to its after, and after will move to the current dot next, that will be a null value. Okay, and since we have broken the link between these two, right? Current dot next should become previous, that is 4, and previous equal to current, right? Previous equal to current and current equal to after. And finally, when we go to the loop, and if the current become null, right? If the current pointer, so always we'll keep the current pointer in mind. Whenever current pointer in mind, if current become null, we are going to close the loop, and you can able to see, right? We have n reversal linked list. So don't worry about these null pointers. Ignore that because our head is kept here and tail is kept here, right? Now from the head 5, 4, 3, 2, 1, the linked list will look like that. So 5, 4, 3, 2, 1, since 2, 1, and the tail will points to 1 and the head will points to 5, and if we start iterating from the head, we'll have 5, 4, 3, 2, 1, and ignore about these nulls, those won't be considered. Okay, so like that you can reverse your linked list. Okay, now we'll try to implement what we have learned. Okay, we have this linked list which was already there, and we have head node and tail node. So we got head and tail to our reverse method, and we have to reverse the linked list. So here the linked list starts from the head. So initially we'll do one thing. We'll try to execute this code and see how it will print the output. Okay, I'm just going to right click, run as Java application, and you can able to see it 1, 2, 3, 4, 5. So if you print head, head will be printed like this. Now you have to reverse, and the reverse should look like 5 should come before and up to so on the null value. Okay, so we'll write the code. So we have head and tail as a first step in the code we discussed, right? We have to change head to tail and tail to head, right? And before that, every time when we are doing any coding, first thing you have to check for some edge cases. First, you have to validate given input is correct or not. So for that, first you have to check that if the given head is null, or similarly given tail is null, that means the given input is invalid. You are not going to do anything. You just return. Okay. And if you have some values in the head, so we'll start our processing as I mentioned in that flow. First thing we need to change head and tails. And before that, we'll have to take a node. I will mention that node name is current node. Okay. Current equal to, as of now, we'll store that current head, and after that we'll point the current head to the tail and current tail to the head that was stored in current pointer. I am going to use current. Like this, we have pointed the current tail to the new head and previous head to the new tail. Okay, so tail and head pointers has been changed. Now we'll start our reverse. So we have to create 3 pointers as I discussed. The first pointer is previous pointer, that is pre, equal to, initially as we discussed, it should be null. And the second pointer is current. As of now we have already created the current here, and the third pointer is after. So this after pointer is nothing but the current pointer next reference. Okay, initially we will start like this. Now we are going to loop through the linked list like while current not equal to null. So as we discussed in the previous animation or diagram, the current should not be equal to null. So when it becomes null, when it reaches all the way to the end of the linked list, then only the current will become null. So that's why I'm using this while loop, and current should not be equal null. Until then this while loop will iterate. Now inside the first condition, every time we have to ensure is we are keeping the next chain. So current dot next. So initially anyway that points to current dot next only, but each iteration we are keeping the next chain, right? Without breaking any chain, we are keeping in after. Okay, and after that what we are going to do, we are breaking the chain, right? So how we are breaking the chain? We are moving the current dot next to the previous element, right? Current dot next earlier is after, right? But now current dot next is pointing to previous, that is in the first scenario it is null, so the chain has been broken. But don't worry, we are storing that change in after variable. Now in the next step we will move our previous element to the current element, right? Current, and now current should at the end should point the after variable, okay, after pointer, and the next iteration after should give the current dot next. Anyway, the current is nothing but after only at the end, right? So it will have another chain, and in the next step we'll break that chain and point to its previous element, and again we will change the current. So at the end of this loop, since here if you see we are doing current dot next, current dot next, current dot next, after the end of the loop the current will become null, the loop will be broken. So that's it, guys. You have reversed your linked list successfully, right? We'll see how it will work now. So I'm using a system.out.println and printing the head here. After the reversal, we'll see how the value will be printed. Yep. So if you see here, this is 1, 2, 3, 4, 5, which is from this system.out.println, which is before reversal. And after that, this reverse method taken head and a tail, and it processed that, and we have written a logic to reverse our linked list. And finally, if we are printing the head here, you can able to see 5, 4, 3, 2, 1. So we have successfully reversed the linked list without using any additional data steps. That's it, guys. If you like my videos, like, share and subscribe. And if you want to do any coding questions, let me know in the comments. And thanks for watching my videos. Thank you.